So this is going to be kind of part 4 for our Fastener Group 2 drawing set and worksheet. So we've finished these two, or when we left off in part 3. Maybe one thing of note that I'll say off the top here is I still haven't really fine-tuned these a lot. I see I have some line type scales to work with. I think I decided that I would do my next drawing and then work on this later. But one thing I did notice after we finished part 3 is that I eliminated, I'll just go into the model space real quick. I had this line, this continuous line all the way through, which is the separation, the two different parts. And I just had a visible line going across my fastener, and that is its section. So the material's its section. So I trimmed that out so that I can see my fastener not its section and show its details. But so I just wanted to drop that line. I see that it's even an issue in the assignment sheet kind of visual. So I'll probably change it out once I finish this drawing. There's a few things in here that I've liked um, that we've done a little different than what's shown on our Canvas course. I am liking this better this year, and so I'm going to stick with that. And now I'm just going to move into the last section here, the last problem number. So let me pull up my maybe I don't have my Word document up anymore. Let me just pull up my Word document for Fastener Work Group, this one here. So I'm happy with this. I'm moving on now to the this one here, D, problem D here. So draw a square head set screw with a full dog point, 5/8 18, UNF, fine, and 3 inches long. So if I go down to that worksheet, and it's going to look like this. This is an accurate look. Um, it's kind of similar to a hex head in some ways. So if I just talk about this is a set screw. A set screw, it seems like it's always helpful to think about these things as they look. Let me do just a quick little search. So a set screw, I mean, just image wise, I guess we have an image of it. Um, all I'm just doing is kind of considering what is a set screw for some of us that, this mechanical world is new to us, I understand, to some of us. And so we haven't. So a set screw are these little mini screws. A lot of them that are socket head type set screws. Quite a few of them are pretty common to have a set screw with a socket head type. Ours is going to be this kind of square. Ours is a really beefy set screw, actually, in some ways. It's a 5/8 set screw. It's got a square head. It's made to really be able to apply some torque to it. That square head will allow us to even torque these down. And for a large set screw is maybe more robust than even these internal type set screw driver bit type um, set screws. So, and then the dog point is not all set screws have this like just cylindrical shaped feature at the end. It's really made to insert into kind of the indentation on the shaft. And so what I want to look up now real quick is just kind of an application of that. So I just want to kind of see, they show, I know they show the individual set screws, but let me see, like the set screw, I'm looking for some imagery that shows the set screw, like set screw in a shaft, or how it would look if it was not even a shaft and a hub assembly is what I'm kind of looking for. And so my initial imagery doesn't show exactly what I'm looking exactly. Well, I don't know. Some of it is what might be okay. Yeah, maybe even just if I look at this imagery here. So if I look at, yeah, this is a set screw in kind of a hub, like we've drawn a hub, we've kind of drawn a keyed hub, but this is one that doesn't have a key in it. And so this hub might be fitting around a shaft like a collar. And we slide our shaft in here. So we've been talking about the difference between hole and shaft size tolerances and all that jazz. So we have this other little image here where there's this this shaft sliding through our hub or collar, and then we put a set screw in maybe and the set screw would just continue to tighten until it puts pressure on this puts pressure on the shaft and kind of holds it in this collar and locks it in place so it can't maybe slip. That shaft can't slip out of this collar. Oh yeah, it shows it right here how it would dive in. Oh, I like this imagery right here actually. And not that I can zoom in exactly to that, but maybe kind of not too good. Yeah, I like this, and it shows that that's really what a set screw does. This is a pretty exaggerated pointed set screw, but it's going to go in and bite against it. Sometimes the set screws are actually a little more flattened, and the way they bite in is with a little more contact. Anyway, not just a point biting into it, but actually the end of the screw like biting in and creating a little more surface contact against the collar to hold it in place, or the shaft, sorry. And then the dog point is almost like if I would take my shaft and kind of like before I put the set screw in, like drill a little recess into the shaft. So it's got like a little cylindrical recess that I've drilled into it. And then my dog point set screw might initially like that cylindrical dog point end of my set screw will slide into a recess on the shaft and really pin it in together, right? Like it's not like a permanent pin, but it definitely is like more than just a set screw biting against a shaft to hold something in place. It's actually like got a recess into whatever it's going into to additionally kind of allow it to be a locked in position set screw. So it's a dog point set screw. Ours is super heavy duty. It's you would be more common to see these even in some pretty heavy applications with maybe a dog point on them at times. And I'll just get rid of that now. But to see this, you're going to be in a heavy industrial area to see something, this quite, 5/8 in diameter plus that big. It's large equipment, a large set screw. So anyway, just want to say that it's not, maybe it isn't your normal set screw is what I'm saying. You might not, you live your whole life and never see a set screw of such size of this unless you're in a pretty industrial environment. Okay, so let's go look. Let's draw this up. So I think let's see, I think the initial thread note details are here. It's 5/8 18 UNF set screw, 2.5 inches long. Oh, well, wait. This is weird. This is my length. Oh, wait, 2.5. What do I have this here for? I don't know. What is the 2.5? Let me go back up to this. Um, I don't think I need that. I think that should be an NA. There's nothing. Yeah, I don't. It's kind of weird. It's probably how your worksheet came as well. But I've got a 2.5 here. This really is not applicable to the set screw, nor is the part Y thickness. These are not applicable to the set screw. The length is, yes, this is the square head set screw with a full dog point. Great. The major diameter was given in the thread notes, right? So it's 5/8 in diameter. The pitch of that, well, it's a fine thread. This is 18 threads per inch. So that would be my 1 divided by 18, right? It's going to equal, let's do that. Super repeating decimal. We'll just take this out to 0.56, we'll call that. Yeah, 0.56. Let's call that. A few decimal places. Like 0.056. You know what I say that wrong. I get it usually when I type. Even if I say it in my head wrong. Minor diameter is going to be the same. The appendix B, minor diameter is what I'm going to use. I still have that up. It's actually appendix B, minor diameter formula right here, right? I really should copy and paste that from that before. It's okay. It's major diameter minus that constant times pitch. Okay, let's do it. Major diameter. 5/8. It's 0.625. If you don't know that, right? 5 divided by 8, 0.625. Subtract that. What's the formula? Yeah, minus, here's my formula. Minus that, so let me go. Minus, parenthesis, times pitch. Fine thread on that thing, 0.56. And that should be correct. We can apply my 0.56 4 7, or sorry, I'll call that 5 6 4 4. Yeah, 5 6 4 4 is what I call it on my chart here. That's what I get. I might just do just double check. Let me just double check my math again real quick. Let's see if I do it right. Yeah, I like it. I'm happy. Okay. Moving on with across the flats. Yeah, this one. So now I'm going to go to Appendix B. This is like I said, this is kind of an odd fastener, and so just heavy duty, not necessarily odd, just actually heavy duty. And so it's not in the initial Appendix B. It definitely comes as a supplementary one after the Appendix C page. I'm pretty sure we've got to categorize specifically for dog point set screws. Those are cotter pin stuff we use for problem C, problem B. So very last but not least, we got a dog point set screw to do. Let's see if it's got our information. These show some different types of set screws. Um, Pointed ones. Yeah. This one I would call, so just to back up and talk about that set screw. Here's all the I like this. So this just shows a few different head types, some different impact drivers. This one being a very common one, like a hex head, socket head type set screw. I would never want one of those. I know they are out there, but and then this one being a super heavy duty, I can get a wrench on this thing and really reef this down. And then with that dog point, it's especially seated, and so I like this. I like these little columns of the, and they show the different tips in the bottom of set screws. So there's some variation of this. This is what I would say is pretty common to see is one that's kind of just chopped off flat point. It, it's a good set screw. It has a lot of surface, maybe just surface friction with that, the way that would bite into even on a cylindrical shaft. That these tend to like have a lot of surface contact when you bite down on them. The rounded ones would be a little bit less, right? They kind of be this dome part. I haven't seen a lot of those actually in this oval point in my mechanical career. I've seen the dog points, half and fulls for sure. I've seen the pointing ones, and I've seen these a lot too. These things here. So cut point, let's say cut point, oval point, or maybe my less seen and just general applications of mechanical. So definitely have some specific reasons. Ours is dog point, full dog point, it says, which just gives us some dimensions to work with. There's a half of the dog point. Let's just focus on the head first, though. Is the head across the flats we need to know. So there it is. We just make sense out of their variables here, right? So I think there's some details here I don't worry about. So like I know that on this particular sheet they're going to show, especially on the square head, they show some pretty fancy radius. I'm going to do mine very simplified. I mean, this is a schematic thread break off, break view of a schematic view with maybe it's a little more detailed than mine. And these are all schematic views. I can tell that. Actually, all their thread details are schematic. I'm doing simplified, so I'm gonna even simplify some of those fine details. And I'll just do the hex head with a little bit of the relief shown for um for the tool to fit over, to make that easy. It's not totally a sharp corner square head. Looks like it's just D. I think D is also the diameter. So the head across the flats really measures the actual major diameter. So that's the next thing on my list here. Width across the flats is the same as the major diameter. That's 5/8. If I just want to type it as a fraction, I can. That's what I have it here. Width across the corners. I'm assuming that this one show it. K, it's given in half at least. It'd be handy to draw that, but K. Um, I don't know. I'll probably draw it to D and not worry about K. I do have it here though. It's a triangle, right? So I could triangulate my way into this probably. I might just draw this in CAD. Maybe when I'm messing around and drawing this actually in CAD, I'll come back and backfill my. It's a use of CAD can spit me out that dimension. So maybe I'll do that, and then Let me see what the next one. So I'm going to wait on the width across the corners. And then the head height, I do want to know this one. Let's take it. I think I can figure it out. I think it can continue. Head height is a little bit odd looking, but and they're showing you kind of how to lay out the arcs here for maybe just to show that relief, which is not a real critical. I mean, I like to show it. It doesn't have to be the super critical nature that it's. But on the head height, I think it's 3/4 diameter, or yeah, 3/4 major diameter. So that's what this is. Kind of hard to read. That's 3/4 D. 3/4 D. So let's do that. It's 3/4 D. We can just do that now. Diameter 5/8, right? Times 3/4. That's 0.75. So this is likely our head height, 468. Maybe I'll just call it 4688. 4688. I can come back to this one. Let's see here. Full dog point length and full dog point diameter. So let's go back to that sheet. Full dog point. Half the diameter. It's a full dog point. Half dog point, quarter diameter. Okay. Half diameter. Diameter, 5/8, 0.625. We know that by now. And we just need half that. I get to. It's half of 5/8 is 5/16. It's 3/1, 2. Put that in. That's the length, right? And then the full dog point diameter, 3/4 D as well. That is 3/4 D. So it's going to be the same head height as it is the dog point diameter. So I've kind of already got that as 3/4 D, 3/4 D. I like it. Let's just take it from this, the head height, right? Head height matches the dog point diameter. Oh, okay. And that's it for this one, except for that. And I think I just don't need it until I come back to it. Yeah. Got this up. I don't have my other finished drawing. Sometimes I like to reference that other finished drawing. Let me just, I know I can reference it from our Canvas course. Let me just make sure that I know the Canvas real quick. I'll just have it up so we can reference it every once in a while. Just can't remember what I'm in my mind. What I'm thinking is I can't remember if I kind of put some of this like this 37.5 degree drawn 45. Maybe it says that's kind of weird, huh? It's actually 37.5, maybe real on the head, but they've drawn it at 45. I can't remember if I did those details. So I'm kind of just maybe drawing like I did last time, or if I just drew this. I can't remember. I think I did. Yeah, yeah. So I think the way, yeah, yeah. Okay. So just kind of, I'm just making a plan before I get started. This is kind of where I'm headed. So I'll zoom in here a little bit. Pretty sure this line right here, this reference line, it might be in line. It looks like I may have started kind of in line with my other one. I don't know if I'm going to fit it in the same viewport or not. I'm not going to worry too much about that yet. But I do have a construction line. I do think that this is the head diameter from this construction line is the head height, I think is what I call that. And then I just kind of, I think I 45'd into the major diameters there. So it looks like I oriented this way. It could be oriented the other way. I mean, there is no real reason. I bet you it's just because probably this was oriented that way. So I'm kind of following this as at least the head orientation. It does help if I put this on the square and then looked at this on the square. Maybe it's just a little bit of a misleading looking, hard to interpret the head profile. This helps that I think a little bit. Notice it's a square head. And then I look down, I'm like, oh yeah, I see. It's just kind of, it's just a little bit more details to it for one. But so I like this orientation. And I just, and we could draw this. Technically, if I think about my drawing sheet, so I probably change a little bit of this. I drew it like that. I drew it like this the first way, just because it's just how it fits. Zoom out a little bit. on my whole drawing. I was able to fit it all there. Probably could. Looks like I'm getting a little close, right? But this is good. I think this is probably all 1-to-1. I don't know. I'm hoping the scale suspicious. That looks 1-to-1, but I don't know. But I could draw this in the vertical orientation as well. It doesn't have to be in the horizontal orientation. It looks like I say that, oh, I'm a 3/4 scale. So I probably have like caught all this in a 3/4 scale. And that would be sufficient. So if you want to, I mean, if you lay it out this way and it works just fine, even if you have to put another viewport, it's fine. We can definitely piece that together. But I do have some room here. Like I could move this down a little bit, maybe draw it 1-to-1, maybe scale it up 1-to-1. These might fit 1-to-1 as well. I'm kind of wondering if I can fit these all 1-to-1 if I kind of turn this way. And this, second time me drawing, I'm just kind of wondering if I'm going to refine my drawing a little bit. Pretty common. If you've drawn something more than once that you might refine it a second time. I feel like I might orient this to get them 1-to-1 with this one next to this one in the vertical position. I'll do that this time on this video. Let's do it. So back in here to model space, I think I have my data up for this. I just minimize that a little bit so I can drag it on and off screen. Yeah, so maybe I'll just even plan on it'll be a new viewport over here. Maybe I'll just plan on I'll just make the plan. Let's do it. Turn on my construction work. I'll also make a new line. I think I'll just take off from where this head height is, crossed here. Probably switch to construction. So let's draw that across. Maybe I'll get myself a center line to work from here. Yeah, that'll be great. How about the midpoint of that line that I just pulled? And I'm going to have a top view, and I'm going to have something like this. So this is just me getting an error here, but I slightly wonder if I pulled that off out of alignment. I don't think so. 2 decimal places, it's 90. Okay, good. I saw 90, but I wiggled just a little bit at the end, so I wanted, okay. I'm going to start with the top view here too, and I think I will use polygon, 4 sides, center polygon. Remember how big this is going to be. Let's just see. Circumscribed about, I think. That's across the flats. Yeah, that's kind of what I want to know. I mean, I'm going to orient it like this, right? I'm going to orient, could be a little tricky. I might rotate it after I place it. The width across the flats, and this is half the width across the flats. I'm going to pull, oh, I have my sheet up here. Widths across the flats, 5/8. So half of that is this what's on here, 5/16, 3/125. So I'm going to do, that's going to be my width across the flats. I'm just seeing that I can't quite in this pull that, and the other way it's going to pull it to the point. I don't know that dimension. So I'm just kind of cheating for a minute and say, oh, this is 0.3125. And so that's a 5/8 diameter. I'm going to rotate this object though by the center, but this is the geometric center showing up. I'm going to rotate it 90 degrees though. Yeah, so I have that. I think I just rotate it 90. Oh, 45. Sorry, let's do that again. Undo. Rotate. By the center. Yeah, like that. I like this. I'm gonna draw it like this. This should be the only dimension I had was the width across the flats here, 0.65. Now what I was saying is I can use CAD to kind of figure out what my width across to fill my worksheet out. I can actually get that right now. It's going to be from point here to point here, 8839. So I'm going to write that down. 8839. I'm going to use that to back right here. 0.8839. Then my worksheet's pretty much done. Okay. Save. Okay. Well, that was not my right save. Sorry, I wanted to make it. Yeah. Let's see. Let's do some projection and get that head diameter built, right? So I think so. Let's construct. And this is no particular measurement away from that. I don't even know what it is. I could check, but it's this, I really didn't place it. Yeah, almost not quite 2 inches, 1.79. That's plenty. Fine. I think that's fine. I didn't really measure this one. This one I am going to keep in the view though. So, you know, maybe I might have to slide it up or down that. That'd be easy to change. That's really the finished. Oh, maybe I did add some more details to that view. Did I? Because it could kind of technically have like a circle look there. Let me check what I did. I don't think so. I think I just finished it with a square. Technically, it would probably look like it had a circle there from kind of edge to edge, kind of like the hex head. Sorry, we didn't. We wanted to always refine things a little bit, right? And I visualized that this would technically kind of look like a hex head when it was finished, which was like with the circle diameter, circle radius, pulling the circle out to here. Like I feel like this is actually kind of what that head would really look like. Just got a little relief going out to the corners. It's kind of pulling down on every corner. So I think I'll add that detail. That's the only thing that I'm really going to add to the top view. And then we project points down. This is going to be my head. Um, well, this gets a little interesting from what I remember too. Let's just going to project it down to here at the center one already. Need the head height here. So I might I'm going to kind of get a line over a line. That'll be okay. I'm going to do a construction line. It's just going to be this head diameter right here. So I'm going to have this piece that I can offset for a head height, I think. So I'm going to, here's what I'm going to do. Like if I look at this, if I look at even the example here, it's kind of like a symmetrical little, the way this has been built. I think I'm going to think about this line is where I'm at right now. What do I want to think here? I think I'm going to think here is where I'm at with that line that I have. I'm going to offset the head diameter that way, that 3/4 times head diameter. And then I'm going to offset half of that. I'm going to figure out what half that is. And then I'm going to put a center line in here because I think I'm going to draw this either this way or this way. And then I'm just going to mirror over a center line that I have there. So I'm going to kind of think of this head, but I'm also going to put a center line down the head. And so I'm going to go to my chart here. It says my head diameter is my first offset. Is that 8.4688? So I think I'm going to come in here. I'm going to offset this thing. 4688. This. And that's the overall head. And then it's going to 45 down, kind of below surface. That's okay. I'm not going to even show this surface on this particular fastener anyway. I'm going to keep it there, but I'm not going to show this surface line. So there is the overall head height. And then I'm gonna do the half of that. Maybe I can use this calculator if it's easier to track of. 4688 is what I offset that, right? And I'm just going to divide that by 2, 3, 4. So I'm going to do another offset, and that'll be the center. Yeah, because I don't have the center. I don't have the center mark to draw across. Offset what? 2, 3, 4, 4. Yes, perfect. Okay. There's kind of the center line profile. Now I think I'm going to do like I think I'll just do this like oh, this one is a little different, huh? Because I don't have a flat that I'm looking at. I'm looking at foreshortened surface. So this is going to look like kind of a come down to a point and come back up like an arc like that is what I can visualize. Let me see. Maybe I will follow. Maybe I'll try to follow what they say. They say, oh, you could do 2.5 times the diameter or K. That's kind of interesting. K. Let's think of how I want to do that arc. Technically, maybe it is. Maybe it actually will work to pull from point to point. I don't know. It's just a small detail, so maybe I don't need to worry about this too much. Maybe I will try to. Let me see what it looks like just doing it like it was the hex head, which what we did is we came to the top corner. We turned on made sure that we had like 30/60s selected. And then I'm like, there's 30, there's 60. And I pulled this down. And I past halfway of this. I'm looking at this surface, right? And then I came in here with another one, pulled it down 30, 60. I wanted to make them cross. That's that point that I pulled an arc. So let me look at what this looks like. Maybe I'll draw it with visible so we can visualize it. 3-point arc. I think we were pulling. Oh no, we just pulled a circle here actually. Huh? Yeah, first the circle. Let me do that first with construction. Radius circle. This is center. Up to that point. Goes down to there, there. Now when I go to visible object, on a 3-point arc, right? 3-point arc. I'm going to go clear down to this point, up to the quadrant, and then clear down to this point. That might have been how I drew this. Just I could open up that. I don't have that drawing open again. I think maybe, and then I would trace over like this is kind of the head. I already have that line. I might just push it to a visible object. That one is kind of I used offset first, but and that comes in. Yeah, now it's that. This is like I'm gonna just draw this visible line up and over, trace the outside profile. This will get trimmed. Maybe I'll mirror this over real quick. Just want me to full look. We'll take just that piece. I'm gonna mirror over this line. I'm gonna turn off my construction work just a second. One drop in line, which is the center one down, I didn't draw. So it's the corner point. And then I just want to know if I think I probably just trimmed this like I did on the. I think that's how I finished that. I do think so. But I'm not totally finished because what I did is a mirror of that. So I kind of dropped that other lining. So I think that's all I did. I don't think I did anything too fancy. I kind of treated it like it was that hex head. And that's kind of how we did that. So I'm fine with that. I think it looks good. And visually looks correct. And then all we want to do is mirror that geometry over this center line, right? So I think I just want to do a mirror of this piece and then the straight section, this piece. That's really it. Right? I just want to mirror those features over this line. And then I just need to trim that as well. I'll keep my construction stuff. I'll trim this off. Trim that. That's right. And this one will be section. Heck yeah, it's a dog point set screw or square head of the dog point set screw. Cool. Let's throw on the construction. I like it. So now I can do my major. I think I'll do my major and minor diameter, and then I'm going to worry about how that transitions from what I've left off here to, because what I've got is a little fine detail. The only thing I'm going to add, not nearly as critical as this, I'm just going to add that it looks straight like that. So I think I'll do my major diameters, and then how far this is up. Well, that's a good question. I don't know. Here's what I'll do is I'll do a little bit, kind of give myself a little bit of an indicator. From here, it comes over 45. Is that right? Yeah, from kind of where I terminated my relief there, I'm going to just draw a 45 line down. Do that with visible line layer maybe, but eventually this is going to come down here. I'm going to put on. And why am I drawing 45? It's kind of because it says it's 37.5, but it was drawn at 45. I think that means this is drawn at 45. I'm not going to be too critical about that. It's just a visual. I don't need it to be that critical for the visual component that we're doing. But so I'll draw, let me see what 45 looks like. I'm just going to make sure I get that tracking on 45. Visible line. That means from here, be 45 right there. It's going to come down in and maybe intersect my major diameter. So I'll just draw this down in a ways, right? Like that, something like that. This is ready. This is ready to be like terminated against the major diameter. Let's do that. what do I have? I have this huge line across. Well, I'm gonna end up putting a center line on here. I'll use my center line on this one, I guess. Center line down through. Remember how long this thing is? 3 inches? You see that's 2 inches over there to my, I'm just going across like this. For a minute, I'll just tuck this down to here. Then I don't have to overlap into that stuff. Now I'm strategically going to do my offset for my major diameter. 5/8. Half of 5/8 is not up on my calculator anymore, but we can get it there. Delete. Delete. 5/8 is 0.625 divided by 2 is going to be 0.3125. Down by 2. 0.3125 is 5/16, half 5/8. See how repetitive you get in this. You get better at your decimals, fractions. It's just going to happen. Might take some study though. Offset. 3/8 this. This is visible. Good. Major diameter. Minor diameter now. We'll do that offset. 5.644. Probably copy and paste that. Let me see if my calculator will allow that. So I'm pretty sure it does. 5.644 sure does. Divide by 2. Excellent. 0.2822. I'm gonna do that offset. Offset. 0.2822. Good. Push those. Oh, you know one thing I don't have my properties panel up, so I'm gonna push that up. Just because that's usually how I push these two. I don't have to worry about being on the right tab. I just use this. Right. It's pretty. I should have slept in the belt. Didn't save that much time. Okay, so we have to now. Now I'm going to terminate those against that. So I feel like I can trim these out now and clean that up, right? So we're going to just go to trim and get rid of this overdrawn stuff here. Yeah, and I think where these two meet, I think the way we actually ended this was just a line across here. So a visible line where the major intersects that. And so I think I'm going to trim this out. I think this is how it's just trim out that where it meets the major. And I'm going to extend those and meet that little cross in there. That's how I'm going to terminate that. That looks good. Now from here, I'm going to call the head height from here though. This is I mean, I'm a little bit off here. I don't know what this measurement even is. I just kind of figured it out that way. I I don't care which one we choose as which one controls the length, right? Because the next thing I need to do is like finish it off, maybe put the little I'm gonna kind of finish it off as if it's like the end of a normal fastener, and then I'm gonna add the dog point on after that. So I'm gonna kind of show how the threads would finish and they would be tapered just a little bit so that they could ease starting, right? Like a normal fastener end. And then, which I'll just use a 45-degree little chamfer on the end to show that. And then I'll add the dot point. So when so I'm going to off, so I just want to know the length of that. I think when you look at this, the length is taken interestingly, I guess from where I drew. So I'll just, I don't know if that's totally true or not, but it works for me. That's what I want to know. The length is going to be from kind of where I drew the head, right? So that's going to work well. Where I have my construction line right there is kind of where I'm going to take that length from. So I'm going to offset maybe just this chunk that I have here that's on that line. And the length of that was given 3 inches. It's a 3 inch. And let's just double check that includes, does that include the dog point? Well, that maybe is unclear. Is if the see if anything else shows up here. If the dog point is included, I don't think so. I think the 3 inches is really a thread, and the dog point then is added on, whether it's a half or full, by this kind of little add-on. So I think that's how I drew it before. Consider the length to the bottom of threads. And let's do that. It's 3 inches. Let's offset that line. how long our fastener is. It's pretty good. This thing is, so I think I'm gonna offset. I'm just gonna pull it out. If we'll do that, I don't pull it out of alignment. Okay. That's the overall length bottom. Now I'm just gonna offset it a pitch, right? One pitch on here is 0.056 for this particular fastener. I'm gonna offset one more time. 0.056. One pitch. And then I'm gonna draw a line if I'm still on 45. Yep, I am. Good. Let's draw that line and bust. First line I get right there. And then we're gonna set this good. 45, then we're gonna set this good. I think that means everything was drawn a little extra long. So let's go ahead and trim it. And here, let's trim all that. Okay, that's the finish. Now we just need to add the dog point. Hey, this is pretty quick one. I'm gonna notate it, finish our drawing, do it. I mean, I think we got more work to do on the drawing side of things than we actually need to finish it here, so that's good. Dog point. Just need to know the diameter here. What do I want to do? I don't know. I'm just going to put some construction, a little bit of construction line work. I don't know how long it is. Let me look at my chart. First, the length of it. Maybe I'm going to draw this construction line strategically here. The full dog point length is 0.3125. So I'm just going to draw this construction line from the bottom of my fastener. 0.3125. There it is. Now I can offset this. The diameter of that, which is kind of weird, huh? Well, dog point diameter is 0.4688. I should just pull that in right. I should just copy that. Let's see what I can. What? It's divided by 2. I'm going to offset it this. 2, 3, 4, 4. Maybe I already had that up there. Sorry, get out of that. Offset that dog point width. I already got the length drawn in. So really I can turn those visible. And then draw across that. And then we're just not going to show you that hidden line work that would be there, but that's it. That is the full dog point. Now just get center lines on. That's not it yet. Let's see, that's it. This one I cannot stretch back to the right of it. Above and beyond, quarter-inch trisomy. Is that a center mark to that? I can center mark. I'll just check myself a little bit. Here's a center that I can. Here's a circle I can add. Yeah, so that's right to. Well, I don't know. I'm gonna pull my extension. Here's what I'm gonna do. I don't pull my extension to the end here. Then I'll adjust my extension. So I'm adjusting the actual where the grip is pulled. And then I can adjust the extension off my properties palette. The properties panel there. Is that one? Yeah. Right here. This one. Extend that to there. And then I'm just going to do the ASME standard extension here, right? 0.25. Good. A little break in them. I mean, I know I could pull them together, but this is okay. They're just two separate views. You don't always draw those lines here that way. And then I'll turn off my, look at this one. I don't think construction wrong. Do one little slanted back. The center line across this head. Sure, that doesn't belong in the better. I like that. It would have taken precedence in the plot style. Okay. Get rid of my calculator. Let's go to my drawing sheet and let's get that thing scoped in on. So, oh, I didn't ever set it off. There you go. I didn't walk that thing down. Moved it. I think I had it at 1:1. I try to pull this down a bit. I had it actually fitting in there. Not that I can be cited. Kind of these can overlap each other. That's what we do. Like I can actually fix this one. It's kind of overdrawn a bit actually, overextended. And I can even slide this over. Well, hold on a minute. Hold on. I'm gonna make that bigger just a second. So I think what I want to try, this is me having built my other one. I'm starting to kind of arrange my sheet though. I think what I had in mind was to take this. I'm gonna try to push it to 1 to 1. How big is this thing? Let's see here. Resize my viewport maybe. So I don't know. Probably not likely unless I think I'm gonna like 3/4. I could tell that's what I finished on that other one, and I could just see that that's what I'm gonna like. I mean, I could slide these together and do a little custom. I could do custom viewports and do some alignment. I mean, it just depends on how hard I want to work on this, right? So maybe I'm gonna make a compromise here and do 3/4 scale. So I probably don't have that as an option here in this particular. It's a custom scale to make that, so I'll make it. I'll add a scale. It's gonna be 3/4 scale. I'll make these 3/4 or 0.75. Okay. Let's apply that to this one. I'm gonna refine it. Oh, geez. I'm gonna refine that. I think two a little bit. So if I'd say that's 3/4 scale, I'm gonna go ahead and refine the dimensions now on that. And maybe I'll lock that for just a second. I don't know. I'm just kind of refining my drawing from left to right here, just because I know this is my first stuff that I drew. I got to make sure it fits on there first. The spacings on my dimensions are going to change a little bit because I've changed the scale here. So it's not going to help me, my annotated stuff isn't going to help me. It's going to help my text remain size, but the this is going to impact that spacing, and I get a little less critical of this as long I don't. But when I see that it kind of jumps maybe further away from it, uh, the object that I want, I'm going to go in and refine it again. I'm going to go into this viewport. Maybe I'll stop for a minute and I'll apply that same scale to this viewport. So that's that one, which isn't going to really affect that one too much. I like that. So I'm just going to lock that one down. It's going to allow me to resize that a little bit though. Gain some drawing space here. Just tuck that in. Okay. This one here, I'm going to jump into it though. And I think I'm going to refine this a little bit. So this is probably at Yeah. No, I did pull these away a ways. I'm just gonna re-look at them. And I definitely know 0.25 is too far, too close. I don't think I have to be that far away from it. Even this, I think I'm gonna refine the placement of this is gonna come in closer. This one too. Spend that extra time here. This one I might go a little more vertical. I'm watching where it's pointing. I see I don't want to be like up in here. So a little separation. Yeah. Okay. I feel like this one's impacted less, but I could tuck it in a little bit. If you've changed up to 3 decibels, that's fine. Okay. Yeah, some of this I just can tell I got a little wild here. It's just the scaling. Or maybe I never refined it. I don't know. So let me refine a little bit. That's nice. And one more. Yeah, that'll allow me to be jump back out now. It's nice sweater. gonna move that up a little bit. Up, just a little bit. And that's gonna move down to. Not chopping that at all. No. Okay. I'll come back to line type scales when I look at all of them. They're all. I think I'm going to be able to put them all at 3/4 scale. And I think I like the look of this one too. I'm getting look at this. Make sure you don't chop those off because I find that you guys have chopped those off. So watch yourself. Take a pretty good look. And then this one I'm definitely going to move down. I think my strategy was I'm just going to give my revision block a little room. Um, One more, I need to add a viewport layer, right? So I'm gonna jump over to the viewport layer. Sorry, just add a viewport. It's gonna be for the dog head set screw. Hopefully it'll live right here pretty happily. There it is. Jump in there and zoom in on it. We haven't dimensioned it yet. This is gonna be a 3/4 scale as well. It's pretty big, so it's pretty yeah, that's gonna be good. Lock that down. Now off this one. And off this one. Lock, yes. Let's go in here and dimension this one. Get out of my So the way we're going to dimension this is just with a note. I think it's just a simple note. So I'm going to go to my home tab and onto my text layer and add a multi-liter. I think I've showed you there, but you can also grab it here. Here's a multi-liter. And maybe I'll just point to it right here. And I'm going to add the thread note. So this is a local note for this particular drawing. It is a 5/8. So what are we doing over here? I think we're adding, yeah, it's interesting. As you do a thread note, you can break the rule and not do that decimally. So it'll be a 5/8, like dash. Was it 16? What is it? I think it's 16 UNF. Well, 5/8 18 UNF. And I don't really have a classification after that, internal, external, or how loose or what the, oh yeah, they'll have the class of fit or whether it's internal or external. I'm just going to do 18 UNF. And I think I'm going to add the length to it though. Or I could dimension the length. So let's do that. So let's UNF. Ooh, I could add the description below. That's good. Like that's going to be very handy. So I'm going to add that description to it. Square head set screw with full dog point. Am I going to put the length there? Am I going to dimension the length? I can't remember what I did on my last drawing. I think I could add the linear dimension. Probably, yeah, I added the linear dimension. It's 3 inches. 5/8, 18 and 3 inches long. Oh, so I've done some redundancy. If I this is why revisions happen. I feel like I don't need to show the length and call out the length here. So I feel like you have either rule. You could. I was tempted to do that here as well. Oh, see, I'm redundant there too. I dropped the length. I just kept the thread note, dropped the length, and then linearly did the length. Let's keep that standard going on this one here. So I'm going to keep this. I just want to add the description below it for the second line is going to be that square head. This could be hyphen. Square head set screw. And I can do a W. I'm pretty sure I can do just a W slash, just like you'd be shorthand with a full. Yep, full dog point. I think that's it. Full dog point is sufficient with full dog point. I think that's it. This I have control over. I sometimes I get square head set screw. Maybe I'll put the W with full dog point on the same line. I might just try to condense mine. I mean, these your local nodes can get kind of big, and so sometimes I make a more paragraph form than I do like linearly long and take up drawing space. So I think this will fit. I'll check it, but and then I'm going to do the linear length. So I'm going to keep that on dimension. Just a quick dimension. The overall length really was taken, from here to here. So I'll just pull this one. Oh, not there. I gotta think about this. Sorry. Mine is probably not the right. It's here to here. That's the choose. That's where my length is taken. Let me just adjust my extension lines to the actual object edge. Wherever that is, this one's going to be what meets there. And up here is probably going to break away from that. So I'm going to try to track this just to where it hits there. 3 inches. That's good. There's the description. Let's jump back out. So looking at line types. Let's fix this so I can see the description. Why do I have to go clear out to there? Further, maybe a little further. Something like that. Good on the height. Getting on the sheet though. I don't really feel like I'm going to necessarily worry about aligning anything in common between those two. I'm just going to place that like that. We get into these things and just turn off my graph. It's a little bit annoying. Square head dog. Square head set screw with full dog corner. Is that what we call it inside the sheet? I'm just kind of checking this out. Square head set screw with full dog. I think I've done square head set screw with full dog. Now I feel like I am ready for kind of line type scale, which is just going to be center lines for the most part, right? So I'm at 3/4 scale. This is going to be good. I haven't filled out my title block yet. I can remember that. Let's set these line type scales. I'm in here. Half scale. That looks pretty good. Yeah, some of you that center lines are notorious for not looking like my extension lines are in the right place, especially if my center line type scale isn't fine enough. That's why sometimes that's why I can see it on your guys' drawings is that the center line is too coarse, and I can usually see that if you would have adjusted the center line type scale, you would have noticed the extension line from the dimension coming across. So it's pretty like it's usually like if you adjust your line type scales, you'll catch yourself um, with extension lines that are. I think that's really sufficient, but it's just to get down to half is on the just on those particularly this one. Might not be enough to break that up. I might still, this is a unique one, so then I'll go, there we go. I got a little breakup shown. But yeah, I mean, there's an argument I could go a little closer. That's great. We'll start finding it. Yeah. So, oh, one last thing that sometimes when I have multiple, like different parts on the same drawing, I didn't do this on the last one either, but I sometimes I will draw just here on like I could do a border sheet. I mean that would be fine. I think that's what I'll do. I'll do a border sheet. That's what this slide type is. That's on the border. Um, and I might just do a line. So I'm out here on the paper. I'm not in any viewport. I'm just out here, clear out on the paper. So, some places will want you to break up break up those views. And so what I'll do, and I'll just do it like a simplified, like it can be pretty rudimentary here. Sometimes I will use some geometry that's on the sheet. Like I can tell, just me, I might pull a line from here up just straight vertical. And this is going to just be a border. It's going to kind of separate these two different things from each other. It's almost like I'm breaking up my sheet on the sheet itself. Of course, now it conflicts with my viewport. So I'm going to say, well, I'm going to move this over just a little bit now and get off. If I'm really going to separate these views a little more like this, that's good. And then I don't really have to adjust the viewport all that much. Doesn't really matter. But as long as the words and everything are in this view. So there's one breakup. And then maybe I'll just do another vertical one. And I don't really have to worry about like I'll use, yeah, let's do this. I see a good spot. Like if I just aim for this, and then I'm just going to take it all the way up to lock it in there. If the revision history block starts to grow, of course I'll have to adjust this so it doesn't ride across my revision history. But initially for this first, Rev 0, this will be great. It'll break up my 3 views here, 3 different parts, or yeah, essentially I have 3. I kind of have 4. I guess there's an argument made, but those go together. That top and I don't know. I'm going to keep these in one. I mean, you could argue, well, I'll separate that too. I'm like, well, I'm going to kind of keep these as like working together as one. They're not the same part. So that's, anyway, there's always an argument. I argue with myself in these videos quite a bit. Huh? This is what goes on in my head as a drafter. You get to see the inside brain workings of a drafter for free of charge, not free of charge. You paid for it. Approved. My name. Let's get this thing signed off, right? This is the 11th. Maybe this is Veterans Day of 2025. Veterans Day. Very cool. And oh, this I usually just try send. Production. Specifically spelled correctly or spelled correctly. Rev 0, I always put NA on these sheets and zone, and I think I said that I'm going to change that in the future, but for now, I've just been leaving it. I don't change a horse midstream all the time. For sure, I need to change this to a 3/4. And I'm the drawer. It's a B-size sheet. Today's date as well. Different format also, but yeah. For me, this is a CAD 1108 Fastener Group 2. The rest we can leave. Yeah, I think this is a done deal. So this is like part 4 of our Fastener Group 2 set. I'm gonna just Control P and just check my PDF. See how that looks. Yeah, it's gonna look pretty good. Those kind of pop out as kind of a big border separation. It could be arguable that maybe I don't want to use the border layer for those. Maybe I could just use like a visible layer, but I don't know. It matches pretty good, right? That's the border. The border layers. My title block was built on the border layer, so they're all pretty bold lines. There's an argument I could. Maybe that's a little bit heavy for the title block layer, but I think I'm going to keep it. Yeah, nothing really. Probably once I get done with this video, I'll see something catches my eye. But right now, I don't like what I'm seeing. Didn't have to do any custom scales for any view. I just was able to fit them all on. So that's great. Yeah, I mean, I like this for a lot of reasons. Just some of that refinement in the end is what I like. So yeah, let me say okay on this one. Save mine. I want to save. There it is. There it is. Mom's glory. I was going to show it. I was just kind of interested. I know we always look at it in our PDFs in color. But I was slightly just thinking by show you how to like if you're actually going to do it in black and white, it would just be a matter of changing this, in my opinion, in the print style. I think if I preview this, it'll now be in monochrome. Yeah, so this is kind of interesting. This is probably what it will actually look like. I probably should start reviewing that a little bit more. It's going to look like this, and so that's actually looks pretty good. I like just the different line types break up. Tell me the story that I can't see, but I mean, color isn't it's critical. Yeah, cool. Like when I print it for my portfolio, I'm probably gonna print them like, oh, I'm definitely I'm gonna print them like, not going to probably, but I am going to print them like. So I'm gonna probably go through and change. Like this is later when we do portfolio items. Anyway, this is a good portfolio item. It's just a study of fasteners. Is why I feel like it's a good conversation point in an interview. We just nerded out over fasteners, keyways, and key seats, and the things that mechanical drawers need to do. So anyway, catch you on the next one. When I end this video. I'll